every system can be solved using the method of substitution. But there are times when your system looks more complicated. There are systems that will involve the use of other variables. They don't have to be x and y. It could be a and b. It could be p and q. It could be other variables. There could be three of them. It doesn't have to be x and y. It could be x, y, and z, and you end up having more than two equations. But let's say in this case, we have a system with fractions in it. We don't like working with denominator. We want to get rid of them. These denominator are annoying. Divided by 2, divided by 5. How do you undo division? Multiply, yes. If I want to undo the first one, divided by 2, I can multiply it by 2. And I'm going to multiply everything by 2, just to make sure everything is balanced. But there are more than one denominator. I also have a 5 in the denominator. And I'm going to multiply it by 5 as well. If I'm to times it by 2, if I'm to times it by 5, at the end, what would you multiply to the entire equation? Times it by 10. I can times it by 10 to remove the denominator. 15a will be negative 10. Well, at least we will end up with an equation with integers. I don't need to deal with denominator anymore. When I multiply everything here by 10, the first one, 3 times 10, will give us 30, and 30 divided by 2. That's how I end up with 15. And then for the second one, 2 times 10 will be 20, and 20 divided by 5 give us 4. And for the last one, negative 1 times 10 will be negative 10. You don't have to go 10 times 3 divided by 2 or 10 times 2 divided by 5 for each of them. You can start to reduce it right away. And I'm going to do that method for the second equation. For the second equation, what would you multiply to eliminate the denominator? 20? 40? 20? Which number would be the easiest? 20. The 20 is the smallest. I'm not going to use 40. Yeah, 40 will work, but it is going to blow up the numbers as well. 20 is the smallest number that I can use to eliminate the denominator. Think about the lowest common denominator between 4 and 10. 20 will be the number to go with. And once again, I'm not going to multiply 20 by 5 right away. I will try to look for any common factor, like the 20 and the 5 are both divisible by 4, giving us 5 times 5 for the first term. For the middle term, I have 10 in the denominator, and as I times it by 20, the leftover will now be 2 times. This is what we will end up with. And now I can isolate one of the two variables using one of the two equations here. Which equation looks easier to work with? First one? Okay. Sure. If we are to start with the first one, do you want to single out A or B? You want to single out A? Okay, sure. Some people may find it the other way. Some people may prefer isolating the B instead. But let's say if we want to single out the A, I'll keep the A on one side, and if it comes with a number in front of A, I will get rid of this using a division. This is what we are getting for A. I will now substitute this to the second equation. For whatever I see here, wherever I see A, I will replace this with that. 25 times A minus 60 equals negative 80. And I go from there. Or I distribute the 25. Seeing how 25 and 15 are both divisible by 5, I'll make the number smaller first. So we have negative 20b minus 50 divided by 3 here and there. But still, we are getting a denominator. What can you do to eliminate the denominator in this case? Multiply everything by 3. I'll times it by 3, times it by 3, times it by 3. For the first one, if I'm to times it by 3, it is going to eliminate the denominator. If I'm to times it by 3, that would give us 18b. If I'm to times it by 3, it would give us negative 240. Once I times everything by 3, the denominator will be gone, giving us a better equation to solve. Negative 38b equals negative 190. Group the like terms together and solve. Once I have b equals 5, we can now sub it back and find the value of a. Negative 4 times 5 will be negative 20. Negative 20 minus 10 will be negative 30. As you divide it by 15, that will give us negative 2 for A. You can always check your solution by putting these numbers back to the question itself. If I'm to use negative 2 for A and positive 5 for B, if I'm to put it here and there, I would expect to get negative 1 for the first equation. If I'm to put those numbers into the second equation, I would expect to get negative 4. This is how I can check my solution if I'm to solve it algebraically.